Okay, so Diane pulls a sled along a snow path on a level ground with her little brother Jasper. Riding the sled, the total mass of Jasper in the sled is 26 kilograms. The cord makes a 20-degree angle with the ground. As a simplified model, assume that the force of friction on the sled is determined by mu kinetic equals 0.16. Even though the surface are not dry, some snow melts as the runners slide along it. Find A, the work done by Diane, and B, the work done by the ground on the sled, while the sled moves 120 meters along the path at a constant 3 kilometers per hour. And C, what is the total work done by the sled? So, starting So to find the work done by a force on an object, we need to know the magnitudes and the direction of the force and the displacement of the object. So the sled's acceleration is 0, so that all the external forces like gravity, friction, and the tensions in the rope, and the normal force in the rope is going to be 0. And then I drew my force body diagram up here to describe the image that it shows and the forces that are on it. So the force body diagram shows that the x and y axis are parallel and perpendicular to the ground, respectively. And after I put the tension and everything into its components, I applied Newton's second law, and it gives me the formulas. The sum of the forces in the x direction is equal to the positive tension times cosine theta minus friction of kinetic is equal to 0. And then sum of the forces in the y direction is the positive tension sine angle theta minus mg plus n is equal to 0. And now this means that T is in tension and the angle is 20 degrees. So the force of kinetic friction is mu Kn. And then all I did was substitute this equation into the first equation is the sum of the forces in the x direction to get the tension of cosine theta minus mu sub k times normal force is equal to 0. And then from there, to find tension, we need to eliminate the unknown. We do that by combining the second equation and multiply it to get the mu sub k times tension times sine of angle theta minus mu sub k times mg plus mu sub k times m is equal to 0. And adding the third equation and the fourth equation also eliminates the normal force, and then we're able to sub for T, which is T cosine of angle theta plus mu sub k times tension times sine of angle theta minus u sub k times mg is equal to 0. Then we set T to equal to mu sub k times mg divided by u sub k times sine of angle theta plus cosine of angle theta. Then I plugged in my values for this, and that gives us 41 newtons right here. And then now we know the tension, we can find the work done by Diane. So the component of the tension Tx is T sub x equal to T cosine theta, and the displacement is change in x is equal to 120 meters. So the work done by Diane is equal to this formula right here. So, which is W sub T is equal to T times cosine angle theta times the change in x. And I plugged my values right here, and then I got it is equal to positive 4,600 joules. And then for part B, the force on the sled due to the ground has two components, N and the F sub K. And the normal force doesn't do any work since it's perpendicular to the displacement of the sled. Now, friction does act in a direction opposite of the displacement, so it has to be 180 degrees. So the formula is W sub F is equal to F sub K times the change in x times cosine of 180 degrees. So you get negative x sub K, negative F, sorry. And then from here, we get F sub K is equal to tension times cosine angle theta. So then that means that the work done by the ground and done by the friction force, which is done by a formula here, which is W sub F, which is equal to negative F sub K times the change in X, which is equal to negative tension times cosine angle theta times the change in X. This gives you W sub F equals negative the 4,600 joules. And then moving on to part C, the tension and the friction are the only force that do work on the sled. So the normal force and gravity are both perpendicular, which is displacement, so they do zero work. So this gives us an equation. W subtotal is equal to W sub T is plus W sub F is equal to 4,600 joules plus negative 4,600 joules, which again gives us a value of 0, which means they both do zero work.